The ExoMars trace gas orbiter, seen here at the Baikonur Cosmodrome in Kazakhstan, being attached to the launch vehicle Adapter. After being reconnected with its lander, it's now being filled with 2.5 tons of propellant ready for launch. The first of Europe and Russia's 2 ExoMars missions will use a Proton rocket to begin its 7-month journey to Mars. ExoMars 2016 consists of the trace gas orbiter and an entry, descent and landing demonstrator module called Schiaparelli. Together, this joint European and Russian mission will test key exploration technologies and also search for evidence of methane and other rare gases in the Martian atmosphere. These gases could result from geological processes, or they could be signatures of current biological activity on the planet.
ExoMars is the dream mission. It's the mission where we are expecting to get the answer to the questions we have about Mars. Its life, its evolution, but also how or what does it mean for the whole evolution of the solar system, including Earth.
3 days before reaching Mars, Schiaparelli will separate from the orbiter and coast towards the planet in hibernation mode to reduce power consumption. It will then reactivate a few hours before entering the Martian atmosphere at 21,000 kilometers per hour. This speed will be reduced by a protective aerodynamic heat shield and a parachute. Thrusters will slow the lander even further until they're cut off 2 meters above the surface. The lander will then free fall to touchdown at just a few meters per second. In less than 6 minutes, Schiaparelli will go from entering the atmosphere to landing on Mars. At this ESA facility in the Netherlands, a Mars yard helps scientists prepare for the Martian surface. But the lander demonstrator's journey through the atmosphere is equally important.
Since it will be the first mission landing during the global dust storm season, we will conduct measurements during the descent that will allow us to determine important parameters of the atmosphere at this time of the year that has not been studied so much. So all of these will feed forward to other missions and our own industry in Europe that may want to try to land also during this time of the year. And of course it will be important for future missions, including astronaut missions.
After separating from Schiaparelli, the trace gas orbiter will use a series of aerobraking manoeuvres over several months to eventually enter a circular orbit 400 kilometers above the surface. It will act as a telecommunications platform and science observatory. Its 4 onboard instruments include a high-resolution stereo camera, sensors that can detect and analyse the small amount of trace gases that make up less than 1% of the atmosphere, and a detector that will map water on and near the surface. Learning more about Mars's water and environment will shed further light on this planet, while knowing the origin of its methane could finally answer the exciting question of whether there is life on Mars.